Go ahead and try and kill two birds with the one stone here and prove both the fourth index and the fifth index law with one foul swoop, because they naturally flow on from each other. And we're going to do that by showing a pattern. Now this pattern works for any number. I've decided to call A2. You can see here I've already done the sums, or just to try and make this a simpler process. So I've called A2, you can call it whatever you like. We might get time to do 5 as well, just because we can. 2 to the power of 4 equals 2 times 2 4 times, which equals 16, and you can see, and so on and so on. If you look there, you can see a pattern. 16 divided by A equals 8, or 16 divided by 2 equals 8. Divide that by 2 again, and you get 4. Divide that by 2 again, and you get 2. And divide that by 2 again, or A again, and you get 1. That is why, using that pattern, 2 to the power of 0 equals 1. And for that pattern then flows on when we start talking about to the negative index, or to the negative exponent. You can see then you've got 2 to the negative 1 equals 1 over 2. Interestingly, that pattern still goes on further, because when you've got 2 to the negative 2, you've got 1 over 2 times 2, which is 1 over 4, and that's the power. So yeah, that's proven why 2 to the power of 0 equals 1. And we'll continue on, just so that you can see this with a different number. So now we're going to call A5, and this time I'm going to start just with A cubed. So A cubed, which equals 5 times 5 times 5, which equals 5 times 5 is 25 times 5 is 125. A squared equals 5 times 5, which equals 25, and then A to the power of 1 just equals 5 by itself. A to the power of 0 equals 1, because most numbers, when to the power of 0, equals 1. Interestingly, while I'm there, 0 to the power of 0 is undefinable. You can't do it, it's impossible. That's the only exception to this law. So, and we're going to follow this on this time, and we're going to go A to the power of negative 1. Whoops. Just rub that out. A to the power of negative 1 and A to the power of negative 2. Just to do that. Okay, so that's going to equal A to the power of negative 1, which is we get the reciprocal, which is 1 over 5, and then we get 1 over 5 squared, which is 1 over 25, proving the next index law, which is A to the negative n equals equals 1 over A to the power of m. And that's kind of nice and easy. You can see the pattern still works that we described in the previous one. 125 divided by 5 is 25, divided by 5 again equals 5, divided by 5 again equals 1, divided by 5 again equals 1/5, divided by 5 again equals 1/25. So here we have it. We've proven 2 index laws in the one hit. Very nice trick to learn. If you understand the question why this is, that will help you to remember it in future. We could do it with another one, but I don't really feel that it's needed.